Good morning everyone. Our topic for today is permutation and combination, and it is prepared by yours truly. Learning objectives. At the end of the lesson, the learners should be able to apply and calculate permutation, apply and calculate combination, and compute factorials. Before we start, I want you to think of how many ways you can flip a coin and roll a die. I'll give you a few minutes to visualize your answers. Time is up. How many ways you can flip a coin and roll a die? That's right. There are 2 ways to flip a coin and 6 ways to roll a die. And based on the activity that you have done, any idea on what is the topic for today? That's right. Our topic for today has to do with counting, and it is permutation and combination. What is permutation? Permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangement matters. For example, we have Alice, Bob, Charlie, and if we were going to arrange them in a set, Alice, Bob, and Charlie is different from Bob, Charlie, and Alice. How about combination? Combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of selection does not matter. We will use Alice, Bob, and Charlie as an example. Alice, Bob, and Charlie is the same with Bob, Charlie, and Alice since the order doesn't matter. And there are 2 types of permutation: permutation with repetition and permutation without repetition. Permutation without repetition is the easiest to calculate. When a thing has n different types, we have n choices each time. For example, if we have a padlock, there are 10 numbers of them ranges from 0 to 9 and we choose 3 of them, and remember that repetition is allowed. We can have the set of 1, 2, 3, 1, 1, 1, 2, 1, 3, and 3, 3, 3. Since there are 10 numbers to choose from and we choose 3 of them, we can represent this as 10 times 10 times 10, or we can have it as 10 to the power of 3. And we can have this formula, which is n to the power of r, where n is the number of things to choose from and we choose r of them. On the other hand, permutation without repetition is different from permutation with repetition, since we have to reduce the number of choices each time. For example, if we are to arrange the numbers 1, 2, 3 but without repetition, we can have this as follows. As you can see, there is no repetition of all the choices, and each time the number of available choices is reduced. And speaking of the number of choices is reduced each time, we can associate this with the factorial function. Factorial function is a mathematical formula represented by an exclamation mark. In the factorial formula, you must multiply all the integers and positives that exist between the number that appears in the formula and the number 1. And these are just some of the examples of factorial function. 4 times 3 times 2 times 1 is equal to 24. 3 factorial is equal to 3 times 2 times 1 equals 6. And 2 factorial is equal to 2 times 1 equals 2. And 1 factorial is equal to 1. With factorial function, we can generate the formula of permutation without repetition as n factorial, where n is the number of choices to choose from. But there is another formula for permutation without repetition, and that is n factorial over the quantity of n minus r factorial. This formula can be used wherein we are to choose on the number of things to choose from but without repetition. For example, how many ways can first and second place be awarded to 10 people? We let n to be 10 and r be 2 since there are 10 people to choose from, which is the n, and we only choose 2, which is the first place and second place, and it is the r. Moving on, do you have any idea on the example of combination? That's right. Lottery number is a good example of combination wherein there is no repetition. A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In combination, You can select the items in any order. The formula of combination is n factorial over r factorial times the quantity of n minus r factorial. For example, how many ways you can pick a team of 3 people from a group of 10? And remember, the order doesn't matter. Since we are to pick a team of 3 people from group of 10 and the order doesn't matter, we will use the formula for combination. We let n to be 10 since there are 10 people to choose from and we choose 3 of them, which is the r. Then we substitute the values. 10 factorial over the 3 factorial times the quantity of 10 minus 3 factorial, which is 10 factorial over 3 factorial times 7 factorial, which is equal to 120. Now, if we are going to revise the statement like this, how many ways you can pick a president, vice president, and a water boy from a group of 10? What have you noticed to the statement? Yes, the order now does matter. And if the order does matter, what formula will we be using? That's right, we will use the formula of permutation. So we have this, 10 factorial over 10 minus 3 factorial, which is equal to 10 factorial over 7 factorial, which is equal to 720. And for the generalization, the number of ways permutation can have is greater than in combination since the order in permutation does matter, and it is with repetition. When order matters, it is permutation, and when the order doesn't matter, it is combination. To have a better understanding with permutation and combination, we will look to in this table. Permutation is concerned with arranging people, digits, numbers, alphabets, letters, and colors, picking a team captain, pitcher, and shortstop from a group, picking 2 favorite colors in order from a color brochure, and picking first, second, and third place winners. While in combination, it is concerned with selection of menu, food, clothes, subjects, team, and picking 3 team members from a group, picking 2 colors from a color brochure, and picking 3 winners. And for the application, try this one. And for the evaluation, evaluate the following. State if each scenario involves a permutation or a combination. State if each scenario involves a permutation or combination, then find the number of possibilities. Thank you for watching.